Morning, sir. My name is Ashita. I am from SED section. My registration number is 21G21A04M2. My tech talk topic about methodology of feedback amplifier analysis. Let's begin the topic. To analyze the feedback amplifier, it is necessary to go through the following steps. Step 1. To identify the topology. That means type of feedback to identify. To find the type of sampling network by shorting the output, that is V0 equal to 0. If feedback signal XF becomes 0, then we can say that it is a voltage sampling. By operating the output loop such that I0 equal to 0, if feedback signal XF becomes 0, then we can say that it is a current sampling. To find the type of mixing network, if the feedback signal is subtracted from the externally applied signal in a voltage in the input loop, we can say that it is a series mixing. If the feedback signal is subtracted from the externally applied signal as a current in the input loop, we can say that it is a shunt mixing. Thus, by determining the type of sampling network and mixing network, type of feedback amplifiers can be determined. For example, if amplifier uses a voltage sampling and series mixing, then we can say that that is a voltage series amplifier. Step 2. To find out the input and output. For voltage sampling, make V0 equal to 0 by shorting the output. For current sampling, make I0 equal to 0 by opening the output loop. Find the output loop. Third step. Find the output circuit. For series mixing, make IA input equal to 0 by opening the input loop. By shorting the mixing, make VI equal to 0 by shorting the input. Step 2 and step 3 ensure that the feedback is reduced to 0 without alternating the loading on the basic amplifier. Step 4. Optional. That means we can replace each active device by its H parameter model at low frequency. Step 5. To find the open loop gain, that means gain without feedback A of the amplifier. Step 6. Indicate XF and X0 on the circuit and evaluate the beta value. Beta equal to XF into X0. Step 7. From the circuit, we can find out the A and beta and desensitivity and gain with feedback and resistivity with feedback, output resistance with feedback, R-OF. For example, we can see that current series feedback amplifier. From the given figure shows the current series feedback. Figure 5.26 shows the common emitter circuit. It is unbiased RE. The common emitter circuit with the unbiased RE is an example of current series feedback. In this configuration, resistor RE is common to base to emitter input circuit as well as collector to emitter output circuit, and input current IB as well as output current IC, both for through it. The voltage drop across the RE is VF equal to I0 plus IR equal to IERE equal to IC into R0 equal to IC means output current, that is also denoted as negative indication of I0 into RE. This voltage drop shows that the output current being sampled and it is converted to voltage by feedback network. At input the VI is subtracted from Vs to produce the VA. Therefore, the feedback applied in series. Analysis for above circuit diagram. First of all, to identify the topology, by opening the output loop, output current I0 equal to 0, feedback signal becomes 0. then hence it is a current sample. We can say that feedback signal Vi is subtracted from the externally applied signal Vs, and hence it is a series mixing. Combining of two conclusions, we can say that it is a current series feedback amplifier. Next, we can find out the input and output circuit. From the above circuit, redraw with the 5.27 figure. To find input circuit I naught equal to 0, then it appears at the input side. To find output circuit II equal to 0, RE appears at output side. The resulting circuit as shown in the figure. Replace transistor with approximate H parameter equivalent circuit. It shows that H parameter equivalent circuit at low frequency. Find the open current series feedback amplifier is denoted with a GM. GM means to find out the gain. GM equal to I naught by VA. I naught means from the above equivalent circuit minus HFE into IB by VS. VS equal to IB into apply KVL for input loop. We get a VS equal to IB into RE plus IB into HIE plus IB into RE. Substitute the VS value in the GM. Minus HFE by IB into IB is common. RE plus HIE plus RE. Minus HFE, IB get cancelled. Minus HFE by RS plus HIE plus RE. Now we can substitute the values from the circuit on above formula. To indicate the ID and VF and calculate the beta value. Beta value means VF feedback voltage gain by output. VF is IE into RE. It is a negative indication, then we can replace minus I naught into RE by I naught. I naught get cancelled minus RE. Desensitivity. Desensitivity means 1 plus beta of GM. We know that the GM value and beta value, substitute the above equation. GM with feedback. GM equal to GM by desensitivity. We know that the GM and desensitivity values. Voltage gain. AVF equal to V naught by Vs. V naught means output circuit, output voltage. I naught into RL by Vs. I naught by Vs means we can denote it as GMF RL. GMF into RL. RI can be given as RI equal to input resistance to RS plus HI. It is in series, then we can add RS plus HIE plus RE. RIF means RI into desensitivity factor. And R naught output circuit. R naught from the above circuit, there is no any resistor at the present in the output circuit. So output circuit becomes infinity. Output resistance become infinity with feedback. We can calculate R naught into D. We get the R naught equal to infinity. Then R naught of F is also infinity. R dash of OF. ROF is parallel to RF. It is also approximately equal to RF. Then we can put the value RF. Okay, sir. Thank you, sir.